The overall goal of this procedure is to demonstrate how capillary electrophoresis-mass spectrometry, or CEMS, using a sheathless porous tip interface, can be used for the analysis of highly polar and charged metabolites.
As you may know, metabolites can be often charged, and they can be cationic or anionic, and to separate them, electrodriven separations like capillary electrophoresis is the most suitable method. However, in recent years, the sensitivity was not good enough, and that was due to the interfacing, and the method was also not robust. But I think we nicely solved both problems using a sheathless-free interface and to use this new protocol.
Capillary electrophoresis-mass spectrometry using a novel sheathless porous tip interface can be used for addressing key clinical questions in the field of metabolomics. For example, the profiling of highly polar charged metabolites can be easily done with this technology, as compounds are separated on the basis of charge to size ratio. Moreover, this technique is very suited for the profiling of this type of compounds in volume-limited biological samples. A unique feature of the proposed sheathless CEMS methodology is that it can be used for the profiling of anionic and cationic metabolites by only switching the CE voltage polarity and the MS detection polarity.
Generally, people new to this method will struggle because CEMS is considered as a relatively new and complicated technique.
To begin this procedure, place a new bare fused silica cartridge with a porous tip emitter